Assalamu alaikum student. Today we will study halogenation of alkanes. First of all, we discuss the content of lesson. We should know what is halogenation of alkanes. In the third point, we will discuss halogenation of alkane in direct sunlight, and then halogenation in diffuse sunlight, and then the reaction of halogenation and reactivity of halogen atom. In the last, we will discuss the conclusion. Objective of this lesson is student will be able to learn what is halogenation, what are the product of halogenation of alkane in direct and diffuse sunlight, and comparison of reactivity of halogens. First, we should discuss the definition of halogenation. Come to the definition of halogenation. Listen carefully. Halogenation reaction is a chemical reaction between substance and halogen. A substance could be an organic compound in which one and more halogen atoms are incorporated into the molecule of substance. Or we can say that halogenation is a chemical reaction that involves the reaction of compound which what is compound here, that is alkane with halogen, and result in the halogen being added to the compound. Halogenation of alkane produce a hydrocarbon derivative in which one and more halogen atom have been placed substituted for hydrogen atom. Alkane halogenation is an example of substitution reaction. And first of all, we should know what is substitution reaction. A type of reaction that occurs in organic chemistry. A substitution reaction is a chemical reaction in which one part of small reacting molecule replaces an atom of group of atom on hydrocarbon or hydrocarbons derivative. We can say that we are replacing hydrogen with halogen atom, and as a result we are getting substitution reaction. Come to the halogenation of alkane take place in two different way. First of all, if we have direct sunlight, then we will get carbon as well as hydrochloric acid. Look at the halogenation of methane. In case of methane react with chlorine, and when exposed to the direct sunlight, it will form carbon as well as it will form four molecules of HCl. But when we have diffuse sunlight, the mixture of ethene and chlorine exposed to a diffuse sunlight, substitution reaction occur and organic product is giving carbon tetrachloride. And this product is giving after four steps of the reaction. Look at the steps of the reaction. In the first steps, we will get chloromethane CH3Cl, and after CH3Cl, then react with CH3Cl. It is CH3Cl again removing one hydrogen, and we are getting CH2Cl2, and then CH2 again removing another hydrogen. In the last we are getting carbon tetrachloride, and all of these four reactions are occurred in the presence of diffuse sunlight. Look at the reactivity of halogen atom. Reactivity of halogen atom is that fluorine is the most reactive element, then chlorine, then bromine, and iodine. And we can say that the element which is at the top, that is more reactive, and element which is at the lower the in the group of halogen, that is least reactive. Reactivity of halogen atom decreases in the following order. Fluorine is most reactive than chlorine. Chlorine is more reactive than bromine and iodine. And bromine is more reactive than iodine. We shall confine our attention to the chlorine and bromine. Why? Because fluorine is so explosive and reactive, it is difficult to handle, and iodine is generally unreactive. And so we should make the reaction between alkane and chlorine and bromine. These are normally exothermic reaction. Conclusion. In the end, we say that halogenation is a type of reaction that involves the replacement of hydrogen atom with another atom, whereat it ends up as a part of a substance or a compound. In general, during halogenation reaction, there is an addition of one and more halogen atom to a substance. A substance would be alkane.